Hello, my name is Griffin Costello, and I will be going over the first semester in Engineering 2. We started the semester learning a CAD program, or Computer Assisted Design, called Fusion 360, where we designed products such as a beer bottle, a whiskey bottle, a paperclip, and a Lego. During these projects, we learned a lot of important engineering concepts, such as fully defined work and how to use CAD programs to get what we want. All of these concepts were used in the major project of designing a product for any use. In this project, we had to think like an engineer to identify a problem, think of a solution, and use what we learned about engineering to make that solution a reality. The problem I identified was holding my phone up for my physics test, as Mr. Natland would have us hold our phone up to our workspace. I found that resting my phone against a stack of books or a similar solution was very annoying and hard to work with. To solve this problem, I decided I was going to design and 3D print a phone stand to hold my phone looking at my workspace. Originally, I wanted this phone stand to be tilted downward, but after some playing around with the design, I found that having it straight up was a perfect angle. Using what we learned from our previous projects, I designed a phone stand with a base and a vertical post to hold the back of my phone straight up. Some considerations I had to take into account while designing my phone stand was how I would input my phone and how I would hold it up. I decided to leave the side open so I could slide my phone inside while holding it up through the top and bottom. With this, I wanted to make the top and bottom unobtrusive, so I had to make them relatively short, and for the top I had to make sure I did not block the camera. After putting in my initial CAD design, a few issues did arise. Some of those issues were me measuring the depth incorrectly and my phone was just slightly too tight. Another issue was I made the vertical plane too thick as I underestimated the strength of the 3D printed material. I also wanted to differentiate my product and not just make it a full black bland phone stand. To do this, I made an Ace of Spades design in CAD and inserted it into the vertical plane of my phone stand. I chose an Ace of Spades because I enjoy playing card games and I thought it was a nice design. So this is my phone stand product. As you can see, it's split into two pieces. That is, so it fits nicely in the box. Originally, this side view was 10 millimeters thick, shown in my original V1 stand. It was much thicker, it was one piece, and it did not have a design on it. But back here, we'll start on the base and we'll give an overview of the product. So we have just a 5 millimeter base with two extrusions out of it. The first extrusion is a front post designed to keep the phone upright. Right here is where you'd slide the phone in from the side. It's filleted a little bit so it can save a little bit of material and it can also look nicer. This second post is for a tension fit or a press fit in the bottom of the vertical post here. They're both 3 millimeters wide and they'll fit into each other for a very nice fit. So it can hold tightly but also be separated into two pieces. Moving on to the vertical post over here. So first we'll go over the Ace of Spades design. So it's a cutout design of the Ace of Spades, leaving little bits here so it can still be attached, but obviously it lets light through so you can see it when the phone's in there, and it's just a nice design. How I did this was I had a sketch in which I mirrored I had a sketch on a canvas. So I traced the canvas with points, then put a fit point spline on there to trace that, put it down the middle and mirrored it, and then extruded that. Then I did the A and another spade up on the corner, mirrored that, and then mirrored it again so I could get it to the opposite corner. Go ahead and get rid of that. And then we can move up to the top. The top at 164 millimeters, I believe, is how tall the phone is. So I have another 5 millimeter thick part up here, which is just a rectangle, except filleted on both sides to once again save material and to look a bit nicer. So the phone will fit right in there, and this top post is for the same use as the bottom post, except to the top, so it can be nice and snug, along with it being a decently tight fit inside the side. As you can see, it has at first one bar going down, but it splits off because right there in that middle piece is where the phone camera and microphone will be. So it splits off, and I put two separate sketches. Um, These ones it's a little bit off because I actually moved the piece back so you could see both in separate component forms. But these two sketches are separate from the one bar up here, and then those are both filleted as well. And that just allows the camera and the microphones to be unobstructed while using the phone stand. To print my design, I would send it into a program called Eiger.io, and the program would estimate the cost and the materials used so we could keep our product reasonable and cost efficient. Our next project was to design and create a box in the laser cutter for our product. While this sounds like a simple task, we wanted to make this out of a single piece of paper and have it laser cut. While the laser cutter stopped working, we still used our cry-cut machine to achieve the same goal. My initial design was to come up with a two-piece box, kind of like a shoebox that would have a top piece go over a bottom piece. I did this because my design was quite large, but after some consideration, I redesigned my original product to break into two pieces with a tension fit to keep it together. With this redesign of my original product, I was able to make my box out of one sheet of paper, which simplified my manufacturing process. So here's my product box. By redesigning my original product, I was able to get this box to hold a 170 millimeter long, 80 millimeter wide, and 37 millimeter deep object in a paper that is 12 inches tall and 11.5 inches wide. If I go into the sketch, I can show you a few things about this box. The first and major thing that we learned while creating our box was parametric design. Using parametric design, we can assign parameters to different things such as length, depth, and width. We can also use equations of certain parameters to create new parameters. By using parameters, this allows us to assign these to a lot of different dimensions in our sketch. The reason this is good is because if we had to change one of these dimensions, such as length is used extensively throughout my project. Instead of having to go through and change each individual dimension, I can change it in that table, and it will change throughout my project, which makes changing designs very easy and is very good in the long run. Now, about this specific box, we'll start over here on the side tabs. So, these tabs fold in as the objective for our box is to also use as little tape or glue as possible. It will fold along this construction line inward. This will be shown in a video later. These side tabs will fold in and they will be taped to the original box. The reason for this is by taping these squares and folding this tab in, I can stop the side or the top and bottom, which I will show in a bit, from sliding, and also I can connect them to make a very stable platform without having to fold over anything. Now, going to the bottom, this is actually the front piece of the box, as the way you are seeing it now is from the back view. Using this bit from beyond the tabs is actually folding back over the product to protect the product, and also, as I will show in CryCut later, it has some writing on it for the consumer. Another interesting piece about this box is its locking mechanism. Inspired from another design, this locking mechanism has a few parts. Number one is along this 3/4 of a square, this is cut out by the CryCut machine, making a tab that is held in place over here. This will go into a tab on the top, which I will show, and another tab from up top will go into this cutout. This was a little bit of a hiccup in my design process when I first printed the box, as I actually had made these too small, and it was very hard and very dependent on your fold to get this locking mechanism to work. Now, if we go to the top, which is actually the back side of the box, because once again this is a side view, it is pretty much the same concept. Everything past these tabs will fold over, but it will actually fold over the piece from the bottom, making this top tab go into the tab from before, and the tab from before will go through this hole right here. This allows me to create a very stable box with minimal tape and in a 12 by 11.5 inch piece of paper, allowing me to quickly and easily make these boxes which can hold my product very securely. Now, this is very different from my old versions, as this box was very hard to make. As you can see here, this is version number 48 of my box. Now, some of those versions were small changes that I just saved, but I have substantially redesigned the box. Looking back in version 5, it was significantly different. These tabs were actually supposed to have tabs from up top, double folding this piece here and folding into the bottom. This was a terrible concept, but it goes to show how hard this design process was, and how many challenges we faced, and how much we learned about not only just a box product, but about engineering in general. So this is the CryCut design space, where we put in our designs for our writing on our boxes, and also where we sent it to the CryCut machine so it can draw and cut our boxes. So as you see here, this is my box design from CAD, but with a couple extra pieces of writing on it. The whole thing in total is 11.5 inches wide and 12.835 inches tall. Originally, my design was about 12.5 inches wide, but seeing as the CryCut machine will not take any design that is over 11.5 inches wide, I had to redesign my box to have a little bit of a shorter width. This was another problem I encountered and had to fix during my engineering process. So here we did a couple of things to try and make it look like a nice product. As you see, starting from the top, I have a double ace of spade design. Here I was going for one ace of spades overlapping another ace of spades, but slightly offset. This was just a nice design, I thought, because not only is it nice, simple for the CryCut machine, as the CryCut machine will only take line art, or very simple lines to create the image. It is also what is on my box. Now, you see some of this text is inverted and some of it is flipped. The reason for this is because you are looking at the back side of it right now, some of this will be folded over. Now, the Ace phone stand, the name, is flipped right now because it will be folded over onto the top, but right under it, the little description of the product is not, because it will be standing straight up. This was something I originally got wrong and had two things flipped where they shouldn't have been, and this was another thing that I had to fix during my process. Another thing I used the drawing feature for was to add a few lines just on some of the fold marks to give an extra point of reference to make a nice fold. Moving to the bottom, As said while going over the design in Fusion 360, this is actually the front of the box, which is why this text, which will actually be on a side of the box, is just a little bit, well, it is flipped. Uh, this instructions will actually be under the top flap. So you will see this once you take, so this design in the Ace phone stand will be covering this instructions until you open the design. This gives a little bit of instructions and a little bit of a warning here where the press fit is actually very tight. As because in the CAD program they're both 3 millimeters, it is a little bit tight to get in and out. Once you do it a few times, it does get a little bit looser and very nice to disassemble and assemble. But for the first few times, it is a little bit tight, and that's just a little warning. Here we have a little description, and obviously the art and the name and the instructions. And this is just to make the box look not as bland, to make it look nicer, and was something that we also talked about in engineering as, for a product design class, we need to market our design, and this box is no simple process. But making a very nice box for a product doesn't matter if the box does not attract anyone to the product. The first step in folding the box is folding the two side tabs in as shown in the video. The second process is to fold all four small tabs inward. Next, you want to fold the top of the box down. Do the same with the bottom box. Then, you want to fold again by the edge of the tab for the top flap. The final step is to put double-sided tape on the back of the small flap. Overall, in the first semester of Engineering 2, we learned a lot of good engineering concepts and skills. We started off learning Fusion 360, as the COVID pandemic prevented us from using SOLIDWORKS as we did in Engineering 1. After that, we truly learned the skill of an engineer as we identified a problem, thought of a solution, and put that solution into reality through our skills with Fusion 360 and 3D printing. We took that one step further by designing and cutting a box, as a box is necessary for the transport and overall safekeeping of a product, and an often overlooked engineering problem, even though it is quite difficult. In both products, we also learned the importance of visuals through artwork on the box and a design on the product that differentiated the product to the market. To round out the semester, we were introduced to the buck and the vacuum press, which makes a plastic mold to securely hold your product inside your box. Unfortunately, I was not able to have time to design my buck, so that is unfinished for me. While I was unable to design a buck, I was thinking about my product's marketing. Because this is a product design course, it is important to know your product's target audience. I designed my product for my own problem, but I thought of who I could market to. My main audience would be students in a similar position where they would need to hold their phone up to show teachers their testing workspace. Once it was complete, I saw it was actually a nice phone stand to have in general, as it was very nice for keeping your phone vertical while also leaving your camera and microphone unobstructed, but you could also turn it on its side and have it stand straight vertical in landscape mode. I learned a lot of engineering concepts and skills during the first semester of Engineering 2, and I look forward to learning even more during second semester.